Stat 1150 numerical summaries. The purpose of this video is to introduce you to single numbers that we use to describe a data set. I used to play a lot of golf. I've kind of gotten more interested in scuba diving lately than golf, so I kind of build my time around that. But I used to play a lot of golf, and sometimes they would say, well, Doug, what kind of golfer are you? And I say, well, on March 15th I shot a 72, and on March 17th I shot a 78, on April 1st I shot, but by the time I would get to like the middle of April, they'd be bored to tears. Because when they ask how good a golfer I am, they didn't want to go into some boring story of every single score that I've shot all year long. What they wanted was just a brief summary of the way I play golf, and something reasonable to report there. It may have been just my average score, right? So that's what we want to get into here. How do we appropriately summarize a lot of data using single numbers? Now, I want to start out with thinking about this. What if I told you the following? Let's say I have a class with only 3 students. They take their first exam and the average score was 80. What can you tell me for sure? What can you tell me for sure without hesitation? Now, some people say, well, there had to be some scores above 80 and there had to be some scores below 80. Well, not necessarily. Turns out all the students may have scored the same, may have scored 80. They say, well, there had to be, one score above 80 and one score below 80. Well, it could be, or it could not be. No one said that it was a 100-point score. Maybe it was a 250-point score. And some student got a I know this is sneaky, but sorry. Somebody got a 240, and 2 people just signed their name and turned in the score, turned in their exam, and got zeros for the score. So anyway, my point is, when you say that you've got an average score of 80, really the only thing that you can say for sure is that the sum of the scores had to be 240. Because guys, when you find the average of a score of scores, essentially what you do is you take the sum of the scores divided by the number of scores that you're given. Now guys, this is because for some students, a fancy schmancy mathematical symbol. This is a sigma. It's a Greek letter, and you shouldn't flip out on me when you see that, because that Greek letter, just mathematically at least, just indicates to add. So add your scores, divide by n, and you get your average. Well guys, if your average is 80 and you have 3 scores, the only way you can get a number divided by 3 equaling 80 is if that number is 240, so that tells me the sum of the scores had to be 240, and you'll see that that is consistent in all 3 data sets. Now, it turns out you could come up with a whole lot of different ones. In fact, you could come up with infinitely many examples of 3 scores that average up to 80. In fact, you could even get really goofy here to have negative 1,000, positive 1,000, and 240. Now, the point I want you to consider is just telling the average score doesn't tell the whole story, does it? Because these data sets that I've given you are completely different, even though the averages are 80. All of these scores, these 3 numbers, those 3 numbers, those, and those, add up to 240. Negative 1,000 plus 1,000 is 0. 0 plus 240 is 240. 240 divided by 3 gives you the average of 80. But there's a bigger picture being made here. There's a more important issue that I want to stress. What makes these data unique are the variation, the consistency. There's no variation here. All 3 students scored the same. There's a little bit more variation here than that data set, but there's not as much variation as there is in this data set. This is just wacky, from negative 1,000 all the way up to positive 1,000 with 240 in the middle. There's all kinds of variation in these scores. In fact, it ranges from what, negative 1,000 all the way up to positive 1,000, where this doesn't range at all. It doesn't vary at all. So, guys, what we want to be able to do is we want to be able to make statistical statements that emphasize two important characteristics of a data set. Now, guys, our focus right now is on quantitative variables. Where we're given numbers, where we're given measurements. So everything I'm teaching you in this data set doesn't apply to like gender, male and female. It doesn't apply to the type of car you drive, Chevrolet, Dodge, Ford, whatever. It deals with numbers, ACT scores, scores shooting golf, things of that nature. But anyway, guys, there's two statements we want to be able to make. The first statement is we want to be able to make a center statement. We want to make a statement about a center of our data set. And what this typically represents is a typical score. Another statement that we want to be able to make is a spread statement. A spread statement taps into the variation that we have in our data set. All right, so let's get busy. Our center statements, there's going to be two types I'm going to teach you. Number one is the mean. Guys, the mean is nothing more than the arithmetic average. And the median is nothing more than the center score when the data are arranged from low to high. So change your data, put it from low to high, come in and find that center score. That's the median. The mean, add them up, divide by how many scores you have. That's called the mean. Guys, we typically call this average, don't we? But now we're getting fancy smancy because we're in big boy, big girl statistics. We're going to call that the mean. The spread statements that I'm going to teach you are the range, the quartiles, the IQR, and the hardest one is called the standard deviation. This is the most complicated. So guys, that's the focus. So let me give you the overall game plan. What I'm going to do is I'm going to give you a very, very small data set. We're going to go through and find all of these by hand, and I'm going to teach you what these things are. So we're going to illustrate how they're calculated. And then I'm going to move over into StatCrunch and show you how to enter these data in by hand and find these numbers the easy way. All right, so that is the game plan. Well, since we're on golf scores, I think data are much more interesting if they have a context. So let's say that I have the following golf scores that I have collected over 7 rounds. So 80, 78, 72, 81, 75, 79, and 81. These days, that's kind of right in target with what I would shoot. I used to be a much better golfer than this, but I just don't take it as seriously anymore. And life got in the way. Life responsibilities got in the way of golf. So, how would we calculate the mean? Well, guys, the mean has a universal symbol called X bar. So when we calculate the mean, we look at the symbol X bar, and this is found by summing up our scores and dividing by the number of scores we have. So guys, we would take 80 plus 78 plus all these other numbers, and we would divide by 7, and I've already done this. The average would be 78. So you might want to add these in. I'll tell you what, I just want to just make sure here. We're not going to use the calculator much, but there are some basic calculations. So I would want to take 80 plus 78 plus 72 plus 81 plus 75 plus 79 plus 81. That all needs to go in parentheses for the obvious reason. Divided by 7 gives me 78. If you don't have a calculator, it's okay, as long as you get my math lab or my stat lab. Remember, those are universal. I'm going to show you how to use StatCrunch. Now, to find the median, as I talked about earlier, you need to be able to arrange the numbers from low to high. So when I just glance at these, I see that the lowest round I shot was a 72, so I'm going to put it first. The next best round was a 75. The next best round was a 78. The next best round was a 79. The next was an 80. And the last was an 81. So I'm a pretty consistent golfer. There's not, oh wait a minute, hold on. 1, 2, 3, there's another 81 there. That's why it's always good to go through and count and make sure you got the same number of numbers that you had when you started out. Now the median, all I got to do is just count to the center, and I can see the 79 is smack dab in the center. So the median of my golf scores would be 79. So half the time I shoot 79 or higher, half the time I shoot 79 or lower. Now, let's move into the measures of variation. They're a little bit harder, not at first, but they're a little bit harder overall, mainly because of the standard deviation. So the first measure of variation that I talked about was the range, and the range is really easy to find. Because it only takes two numbers and requires you to only do a subtraction. So the highest score that I had in these 7 scores was an 81. The lowest score that I had was a 72. So the variation in those scores, according to the range, was 9 strokes. The second one I want to point out are the quartiles. Now, let's step back just a second and think about quartiles. What does the prefix of quartiles indicate to you? When I think of quartiles, quarters, quartiles, I think of force. So a kind of a good way to think about, for example, a quarter is a fourth of a dollar. So in statistics, quartile, kind of a good way to think about this, at least a beginning way to think about it, is imagine you've got a string. And again, quartiles force. So you want to cut this string into 4 equal pieces. What would you do? How many cuts would you need to make? Well, I would make a cut smack dab in the center. So I would have 2 equal pieces of string. For this lower piece of string, I'd make a cut. So I'd have it. In the upper piece, I would make a cut. So I would need to make 3 cuts to cut this into 4 equal pieces. So 25% of my string would be there. 25% of my string is there. 25% in each of these segments, right? Now, this isn't a course in strings. This is a course in data. So now imagine that you can take your data and arrange it from low to high. Make a cut smack dab in the center. Well, we just did that. We've got a big old fancy smancy name for that, don't we? It's called the median. Take what's below the median and cut it in half. Well, guys, that's Q1. Take what's above the median, cut it in half. That's Q3. So guys, what we can say here is Q1 equals 75. So what happens to Q1? 25% of our data approximately are below Q1. Actually, it should be is. Below 75, approximately. Because, you know, there's only 7 pieces of data and 25% doesn't come out to a nice whole number. What can we say about Q3? Well, Q3 is what? It's 81. But in Q3, what do we have? Well, we have a 25 and a 25 and a 25. We have 75% of the information below Q3, so we can say approximately 75% of the data is below 81. Now, natural extension of this is to want to come in and say, well, what's the difference between these two values? Statisticians asked themselves that years ago, and they said, well, we need a big old fancy name for that. And I don't know why they came up with this, but they call it the interquartile range, the IQR. So the IQR is precisely that. It's the difference between Q3 and Q1. If you can subtract, once you find Q3 and Q1, to find the IQR, all you need to do is subtract the two. Q3 is 81. Q1 is 75. 81 minus 75 is 6. So these are important measures, guys, and I don't want you to lose sight of the bigger picture. We have measures of spread, the range so far, the quartiles so far, the IQR so far. Right now, I'm just teaching you what these things are and how to find them. And eventually, I'm going to show you how to do this in StatCrunch. The bigger picture that I'm trying to develop or trying to get to is, when is the quartile better than the range? When is the mean better than the median? When is the standard deviation better than these quartiles and range? So we'll get to that in a later video. Now, the standard deviation is more difficult, and the development of the standard deviation kind of came from this. What statisticians saw is they saw that, well, if I have my data and I can find the median, I can get kind of an indication of spread around the median by finding Q1 and Q3, and if I subtract those, I get the IQR, so it gives me an idea of kind of a spread around the median. But they wanted also to be able to find a spread around the mean. And they thought, well, how are we going to do that? And they thought, well, there's one of the limitations up here is the spread around the median is defined by 2 scores. But they wanted to bring in every single score and kind of get an average distance from the mean. That's what they wanted to do. They wanted to come up, well, we want to get an average distance around the mean. Now, history books show, statistics history books show, that what they did is they started out with a table X is the universal symbol for our overall data set. So they put their data, and I'm sure they weren't looking at golf scores, but they were looking at something. We're going to look at golf scores just because we are. If you don't like golf, don't worry about it. This will probably be the last golf example that I will use the entire semester. Or maybe it won't. I don't know. So anyway, they put their data down in a column left side, and they said, well, let's take these scores and subtract them from the mean, divide this, add all these up, divide by 7, and we'll get an average distance from the mean. Sounds reasonable, right? So they said, well, a score of 80, again, I know they didn't use this data set, but pretend they did, has a distance from the mean of positive 2 because 80 is 2 units above our mean. So it gets a 2. Well, 78 isn't any distance from the mean because it is the mean. That happens sometimes. 72 minus 78 is negative 6 because 72 is 6 units below the mean. So what they want to do, they want to get these distances from the mean, and they want to add all these things up, divide them by 7, and get an average distance from the mean. So 81 minus 78 is negative 3. 75 minus 7, no, it's positive 3, equals negative 3. 79 minus 78 is a positive 1. And 81 minus 78 is a positive 3. So let's add these things up, and then we'll divide by 7, and we'll get an average distance from the mean. So 2 minus 6 is negative 4, plus 3 is negative 1, negative 4, plus 4 is 0. Well, 0 divided by 7 tells us squat nothing. And that's what they found. They found an interesting fact that anytime you sum up these deviations from the mean, you will always get 0, and dividing 0 by the number of data that you have gives you squat nothing. So this happens sometimes in math and statistics and engineering. And what people like to do is when you get this kind of canceling out of positive and negative numbers, they like to square these numbers because squaring gets away from the negatives, right? So then if we sum up these squared deviations, we no longer can get 0. What's 2 squared? What's 0 squared? Negative 6 squared, 3 squared, negative 3 squared, 1 squared, and 3 squared. Now, let's sum those up. So we got what? 4, 36 is 49, 50, 68. So 68 divided by 7 gives us 9.71. But they studied this a little further, and I'm not going to get into why this happened, but they found out that they could come up with a better indication of spread if they didn't divide by n, but they divided by n minus 1. Now guys, this gets into biased and unbiased estimators and things, and I really don't want to get into that at this level of class. But let's just say that it turned out better if they divided by n minus 1 instead of n. Now, let's see what we've got here. What kind of formula have we created? We have taken the x minus x bars squared. We added them up, and we divided by n minus 1. Now, we initially divided by n, but I told you that they found out, again, for reasons that are too sophisticated, too complex for this class, they found out it's easier, or not easier, it's better to divide by n minus 1. They said, well, we need to give this a fancy name. And they called this the variance. So guys, the variance for this problem would be 68 divided by 6, which is 11.33. But somebody said, you know what, let's think about what's going on here. These are scores. This is 80 strokes minus 78 strokes is 2 strokes. 78 strokes minus 78 strokes is 0 strokes. That can be said for all this, can't it? 2 strokes plus 0 strokes plus a negative 6 strokes plus is what? 0 strokes. So we have our unit in the same measurement that we started out with our data set. But guys, what happens when we square these things? We get 4 strokes squared. What in the world is 4 strokes squared? I'm okay with the 4, but what does that unit of measurement, strokes squared, do for us? Confuses the heck out of stuff, doesn't it? So when we add all this stuff up and square it, what we end up with down here is 11.33 strokes squared. And the statisticians thought, well, that's kind of goofy to have a measurement in a different unit that we started out with. Well, we need to get this back to just strokes, and the best way to do that is to take the square root of this value. They needed a big old fancy name for it, and they called it the standard deviation. Guys, the standard deviation is by far the most commonly reported measure of spread that you will find in statistics. So what is the standard deviation? It's the variance taken the square root of. So it's the square root of the variance. So guys, I can take 68 divided by 6, take the square root of 68 divided by 6, and I get the variance of 3.37. Guys, I'm going to take that 0.36, I'm going to, because that third digit is bigger than 5, I'm going to change that to 37. So 3.37. Now, we had a small manageable data set. I mean, this was still kind of a nightmare for some of you, probably. But we had a small manageable data set. Can you imagine having like 760 measurements, 760 golf scores, and try to do this? Well, you wouldn't. You would use technology. So, guys, let's summarize what we've done so far. All right. First of all, we had these 7 golf scores. And those golf scores were 80, 78, 72, 81, 75, 79, and 81. What do we know? Well, we know that N is 7. N stands for the number of scores. We know that the mean was 78. We know the median was 79. We know that the range was what? 9. Oh, shoot, I've got this stuff right here. Yeah. We know the Q1 was 75. We know the Q3 was 81. We know that the IQR was 6. And we know that the standard deviation, which will be one of these two values, or these two symbols, I should say S with a small x as a subscript, or just S, the standard deviation was 3.37. And we know that the variance, which is Sx squared or just S squared, was the 11.33. All right, guys, I want you to go to StatCrunch, and let's get some things done here. All right, so here's what I got. I got my stat lab up, and when I look at this right now, I'm over here, and I've got my assignment manager up, and I look up here and I don't see StatCrunch anywhere. Well, guys, if you just go to main menu, you will see StatCrunch. So click it. And what I want to do now, you can use data sets from your textbook, or you can just go to the website. So I want to go to the website. Lots of options here. What I want to do is I want to type or paste data into a blank table. So it takes me to StatCrunch. Now, first thing I want to do is I want to go up and give my numbers, my variable, a name. So I'm going to call this scores. And then I'm going to type in my data. Now, since I've got my data in, make sure I've got 7. I want to go over to Stat. I want to go to Summary Stat. And I want to go to Column. Guys, the beauty of taking this class online, if things get too fast, hit pause. You can always stop me. See, in a classroom you couldn't. Here you can. Now what I want to do is I want to select scores, so that's what I want, the variable that I want to analyze. And I want to put a bunch of stuff. Now I'm going to get rid of everything over here. There's some things that are pre-selected. So I'm just going to click that and get rid of them. But so I want to find the things that I created by hand. So guys, to select multiple, let's see. I do the command key for a Mac. I think it's actually the control key for Windows. So I want the mean, I want the variance, I want the standard deviation, I want the median, I want the range, I want the Q1, I want the Q3, and I want the IQR. Now there's some other stuff down here that's interesting. Skewness, kurtosis, coefficient of variation, adjusted standard deviation. Those things are interesting, but right now I want to keep it just kind of the basics. All right, come down here to compute. Well, guys, do those numbers look familiar? 7 scores, mean is 78, the variance was 11.33, standard deviation 3.37, the median was 75, the range was 9, IQR was 6, and Q1 and Q3 were equal to 75. Now, let's just say, for example, that I had a little bit more information. And let's say I had it over the day. So let's say that this was shot during the week. This was shot during the week. That was weekend. That was weekend. That was weekend. That was during the weekend. And that was during the week. And I just wanted to take these scores and look at them over, you know, when I shot, whether I'm played better on the weekend or better during the week. Well, it allows you to break things down over a categorical variable. So this day would be categorical because it clearly doesn't have numbers. So I could go stats, summary statistics over columns, and I could do my scores, but I could group them by the day. I'm going to keep these same values over here that I had before because I like them. Okay, and I'm going to go compute, and what you can see here is I get a comparison over weeks and weekends. Now we do these things a lot over gender. We want to see if there's any difference in things across males and females. So you know, any kind of categorical variable, we can look at a quantitative variable over that. So if and I just made this stuff up, so it's really not doesn't mean much, but I had 3 scores during the week and 4 on the weekend. It looks like I played better on the weekend. But when I come to the standard deviation and the variance, you can see that the variation in my scores is a lot more than for the weekend than it is the week because the standard deviation is higher. The range is even higher. There's 9 strokes difference from the high to the low. On weekend, where as I'm more consistent during the week because the range is equal to 3. So kind of cool stuff, you know, really. And my StatCrunch makes it very easy to calculate these summary statistics for the scores. All right. Now, let's have some fun here. Let's go to a demo assignment that I put up. So if you'll go to Assignments, there's a demo StatCrunch, and you're actually going to get, this is actually a quiz. So you're going to click it, and we're going to do some questions. And I'm going to show you how to do them, and you're going to work along with me, and this is going to be treated as a 25-point quiz. Pretty cool when I do them for you, right? Now, this list represents the number of children for the first 6 ladies of a certain country, complete parts A through D. So I got some numbers here. But in in my stat lab, it makes it really easy to import this into StatCrunch. So if I click this, it's going to let me open this up in StatCrunch. Okay, I got a pop-up block, so guys, I need to come up here and always allow. So I'm going to do that again. And notice it's created a new data set, and it's put in the numbers. So there should be, what, 6 numbers? So let's go back and make sure that we do have 6. Now, the mean number is what? Well, let's find it. So the mean number is 3.66666. So let's see how we're supposed to enter this. This is rounded to the nearest tenth, so we would have 3.7. Check our answer. Cool. Interpret the mean. So is the mean is the typical or average number of children birthed? The mean is the difference. It's not a difference. The mean represents the number of children birthed such that half, that's not true, that's the median. The mean represents the most common. It's not the most common. It's the typical or the average. A statistics state that women living around this time tended to have between 7 and 8 children. How does the mean for the ladies compare? Well, it's less than. So we can say the mean birth by these greater than is less than. I'm going to get one wrong here in just a second, just to mess with you. The first lady had 1 that is furthest from the mean. So I'm sorry, first lady number was furthest from the mean. So guys, the mean was 3.7. Which one of these is furthest from 3.7? Well, clearly the first lady number 3. Find the standard deviation. All right, let's do it. So the standard deviation is 2.66. But it probably wants us to enter it as tenths, so 2.66 rounded to the nearest tenth would be 2.7. Alright, so we're done with that one. Now we're going to go to the next. It says the birth weights in grams. Now I'm going to shut this out just to make a point. So the birth weight in grams are given for babies born to 22 mothers who smoked, oh that's awful, during their pregnancy, and to 35 who did not smoke. 7 pounds is about 3,200 grams, complete parts A through D. So click the icon to view the data, and you can see that we've got smoke, and what I want to do is I want to click this, and I want to open in StatCrunch. Now, guys, important point. All right, very important point. we don't have a data set right now. A data set, when you read left to right, and I covered this in the first video, a data set, this information on each line is specific to one individual in our data set. So we've got this, it's called a stacked data set. We don't want that. We want this thing in a regular data set. And I'm going to show you how to do that. So we're going to go to data. We're going to go to row arrange. And we're going to go to stack. Now I want to choose both of these. I want to store my labels in smoke. That's going to be yes or no. I want to store my values in birth weight. So what's going to happen is this is going to give us a true data set, not a stacked data set, because stacked data sets are bad. Now watch what happens. What happens now is we have two variables. We have whether or not they smoked, yes or no, and we have the birth weight. So what I want to do now is I want to come into my data. I want to get rid of this information. All right, how do I do that? Here we go. So I want to go to columns, and I want to delete, and I want to delete that, and I want to delete that. So guys, now I got a true live data set, because when I come down, for example, to row number 17, I know this mother did not smoke, and I know that that value on that line is relevant to that mother. So guys, when I read left to right, I want all the information on this line to be relevant to that particular subject. So let's go over here and see what we got to find here. We've got our things set up. So compare the means and standard deviations in the context. So non-smoking to smoking. So I'm going to go stat, summary statistics, columns. So I want my birth weight grouped by smoking. And really the only thing I need is the mean and the standard deviation. So guys, for the mothers who smoked, the birth weight was quite a bit lower, and there was a lot more variation. So I'm going to go back to my question, and it says round to 2 decimal places. So the birth weight for non-smokers is 3590.29. 3590.29. The mean birth for smoking, 2852.55. 2852.55. The mean birth weight for babies born to non-smoking is what? Well, it's higher, greater than. Standard deviation. Let's go get them. First of all, we want it for non-smoking. So that's 601.01. And for smoking mothers, it's 965.61. So the standard deviation for babies born to non-smoking is less than. Remove the outlier of 847 grams for smoking mothers. Okay, so we need to find 847 for smoking. So I'm going to come in here and I want to clear that one row. Okay. Alright, I think what I'm going to have to do here is I'm going to have to edit, and I'm going to have to go to row, and I'm going to delete. And what row was it? Let me check this out. So it's row 48. Okay, so I got to select it. Okay, that makes sense. So select row 48, edit, row, delete, and compute. Alright, so I've deleted that row, and now what I want to do is I think, go back and do some more stuff. With the outlier removed, the mean, so I need to find the mean again. So let's go to Stat, Summary Stats, Columns, Birth Weight, Cross Smoke. Because I don't need all that stuff, let's just get the mean and the standard deviation. So what do I want first? I want the mean of the smoking mothers. So that's 2948.05. 2948.05. The mean for non-smoking is 3590.29. 3590. And we can say that the mean for non-smoking is less than. No, I'm sorry. The mean weight for born to non-smoking is greater than. With the outlier removed, we're going to do standard deviations. So with non-smoking mothers, the standard deviation was 601.01. And the standard deviation for smoking mothers is 876.55. You might want to write this stuff down. That's usually what I do. So the standard deviation of birth weights for babies born to non-smoking is less than. Okay, so I want you to summarize what you did. Identify the effect of removing the outlier on the standard deviation. Well, what did it do? It decreased the standard deviation. Now, the value that we removed was with the smoking mothers, so it only affected obviously the smoking mothers. But by removing the outlier, we decreased the standard deviation, which is a measure of spread. Now that should make a lot of sense because an outlier is a long way from the mean. That's why we call it an outlier. It's way out there. Well, if we take out the value that is furthest from the mean, then we're going to have less variation around the mean, hence the standard deviation is smaller. So by removing the outlier, the standard deviation decreases. So we know the answer has to be D or A. So just as I said, the value is furthest from the mean has a larger contribution, so it's going to be D. All right, gang, that is it. We are done. Good deal. It's a long video. This is longer than the videos I usually put up, but there was just a lot going on. So, guys, I hope you like StatCrunch. I'm going to tell you right now, it's a lot easier than R. It's a lot easier than your graphing calculator. So, have a good one.